Hello, everyone. So in this video, we'll see how do we formulate the null hypothesis and alternative hypothesis. The first example uh, statement is average sales in metric ton of a company is 500. So as we spoke about, hypothesis always addresses about the population parameters, which means here they are talking about a company, that means a single population. So based on that, first let us define the population mean like this. That mu is equal to population mean sales, average sales in metric ton. So we have defined this. Now our null hypothesis will be no significant difference, which means this mu will be equal to 500. Now, depending on what is to be tested, suppose if the question says that, let's say, check whether, suppose if the question says, check whether the population mean is different from 500 tons, then in that case, our alternative hypothesis will be mu not equal to 500. This is the first possibility. Suppose if the question says, check whether or test whether the population mean is more than 500 tons, maybe they may say in the recent past, then our alternative hypothesis will be mu greater than 500 tons. Similarly, if the question says test whether the population mean is lesser than 500 tons, then our alternative hypothesis will be mu less than 500 tons. Likewise, we can formulate the null hypothesis, which is denoted by H naught, and alternative hypothesis, which are denoted by this H. Let's move on to the next example. Something about two population means. New drug manufactured by a company is more effective than their existing drug as far as the average pain relief in hours is concerned. So again, we need to define that mu1 is equal to mean, or I can say population mean hours of pain relief due to existing drug. Then I can define mu2 is population mean hours of pain relief due to new drug. What is to be tested? Whether the new drug is effective than that of existing drug. In the sense, the new drug should give you more hours of pain relief. That is what it is basically. So our null hypothesis will be there is no significant difference between both the drugs. Means I can say mu1 equal to mu2. That will be our null hypothesis. Alternative hypothesis will be which is better to be tested. New drug means this mu2 is larger than mu1. larger than. Generally, we write 1 first, so I can rewrite this as mu1 lesser than. That is what. That is how you formulate the null and alternative hypothesis. Let's move on to the next example. Here it is talking about a village. So it is a single population. That is why it is single population here. And this 0.3 is a proportion. So you write single population. Now, let's define first. Let small p equal to population proportion of smokers in the village. Now, based on this, I can again say H naught is no significant difference, means it is the same as whatever is stated. Depending on whatever the test may be, you may have one possibility, maybe H0, H1, B1, sorry, B not equal to 0.3. Hence, the population proportion is, if population proportion is, sorry, proportion is different from 0.3. If the question says to test this different from 0.3, then the alternative will be like that. If the population proportion is more than 0.3, if the question says, then it will become P larger than 0.3 in that case. So either this or this population proportion is more than 0.3. If it states like that, then you will have this. Or if the question also can state that now the smokers, has it been reduced or what? It will become population proportion is lesser than 30%, means point. So these are the various possible alternative hypotheses for this particular statement. Let us move on to the next example. Here it is about two population proportions because they are talking about proportion of users after watching advertisement A is more than that of the users after watching advertisement B. So let us define P1 is equal to population proportion of users who watch advertisement. P2 is population proportion of users who watch advertisement. Means basically after watching advertisement A, people who are using that particular product. After watching advertisement B, people who are using that particular product. So now, as usual, null hypothesis will be no significant difference between both the population proportions. So P1 is equal to P2. Or we can also rewrite it as P1 minus P2 is 0. Alternative, here they say proportion of users after watching advertisement A is more than, means P1 is larger than P2. Or we can also put it as minus P2 is greater than P0. That will be your alternative hypothesis for this particular question. For this particular statement. Next, independence of attributes. So, as I was telling, a marketing manager may say that these two variables or these two attributes, sales and liquidation expenses, are related. So he may say that because for that reason only he is spending money on advertising. So that he is expecting, based on the past experience, he is expecting better sales turnover due to advertising. So our null hypothesis will be the same, means not same, sorry. null hypothesis will be the attributes. What are the attributes? Sales and advertising expenses are independent. Means basically I am talking here about not related. There is no effect between these two. That is what will be our null hypothesis. Alternative will be the attributes, sales and advertising expenses are not independent. So that will be the null and alternative hypothesis. Here, the only difference is like you are not putting it as a form of a notation. You are writing it in a descriptive manner. Whenever you come across with such type of test for independence of attributes. This is also called a test for independence of attributes. So next example, more than two population proportions. Right? An insurance company claims that proportion of accidents occur on different days in a week or the same. In a week, there are 7 days. So let me define like this. Let PI is equal to population proportion of accidents occur on ith day. I am generally defining. Then I can say here I is ranging because in a week there are 7 days. I is ranging from 1, 2, 3 up to 7. So that means if I say P1 population proportion of accidents occurs on the first day, second day, like now for this, how the hypothesis will be written? Null hypothesis. No significant difference, which means I will write P1 is the same as P2, is the same as P3, is the same as P4, same as P5, same as P6. Alternative. At least 2 of the above are not the same. That will be your alternative. At least 2 of, I'm sorry. Two of the above proportions. Even a minimum 2 proportions, if it is not same, that means that will become your alternative. At least 2 of the above proportions are not the same. So that way you formulate for more than 2 population proportions. Let's move on to the next. Goodness of fit. Basically, goodness of fit means to check whether a particular data follows a specific probability distribution of. So if the statement says the population data follows a specific probability distribution, in that case, your null hypothesis will be. You agree, data follows the given, whatever may be given. They may say specify it as binomial, they may specify it as uniform, they may specify it as normal, they may specify it as Poisson. Let it be any. So data follows the given probability distribution will be your null hypothesis. And the alternative will be exactly opposite. Data do not follow the given probability distribution. That will be your alternative hypothesis. So we'll end up with this particular session till this. In our subsequent videos, we'll further discuss on testing of hypothesis. Till then, take care. Thank you. See you later.